Today we are going to learn negative binomial regression. We are going to run negative binomial regression. We are going to learn negative binomial regression today. So first of all, we need to know what is the difference. What is the difference between binomial and negative binomial distribution? This is what we first need to know. Okay?
So did you mention the scenarios for Poisson regression?
Yeah, I discussed that thing, right? What is the situation we have to use Poisson distribution?
Count.
What?
Count.
Count data. And then there are two conditions.
Mean and variance should be same.
Okay, fantastic. And then there are two assumptions. There are two assumptions. No? Count data and mean and variance is same. That is a fantastic. There are two assumptions where we need to use Poisson distribution or Poisson regression model. What are the two assumptions? Online people. Two assumptions.
Probability.
Probability.
Greater than 0 and exponential equal to 1.
That is for all distributions.
Density for probability.
No. Probability of success P
Just to include-
and number of events infinity. For example, how many cars by the Macomb railway station transactions in 24 hours? Maybe 100,000 in 24 hours. How many accidents? 1, 2 or 0, right? So probability of accident is very low, right? And number of things is 0. Under these two assumptions, we came from binomial distribution to binomial distributions to Poisson distribution. Remember, this is the thing that I have discussed last class, right? So probability of success in one day or maybe in 1 year, you receive suppose 500 call. How many call drops? 3, 4, 5, something like that, or 10, 15. So suppose 500 call you receive and call drop is suppose 15. So this probability is very small, right? Okay. Under these two assumptions, when we do mathematical operation, we ended up with the Poisson distributions. But what is the difference between binomial distribution and negative binomial distributions? Let me clarify these things very clearly so that you will never forget. So this is the probability distribution function of the binomial distribution, and then Q equal to n minus x, n equal to number of trials, x equal to number of successes, and P equal to probability of success, Q equal to 1 minus P equal to probability of failure, right? And then X takes value what? 0 success, 1 success, 2 success up until n success. Clear, right? For example, in a class there are 40 students, n equal to 40, right? Probability of left-handed equal to 0.10, right? What is the probability that exactly 3 students are left-handed? What is the probability that exactly 3 students are left-handed? 40, choose 3.10 to the power 3, 1 minus 0.10 to the power 40 minus 3 equal to 37, right? You understand these things? Am I going too fast? No, right? Clear, right? Clear. That is the binomial distribution. So binomial distribution, what is number of trials is fixed. And fixed, you know, a hospital has 50 patients, probability of COVID patients is 0.50. What is the probability that 25 of those patients are COVID patients? Understand? N is fixed. Number of trials is fixed, and given at the very beginning. Number of success, probability you are asked to find. Okay. Clear, right? Clear. But this is the binomial distribution. Binomial distribution. What is negative binomial distributions? Negative binomial distribution. Negative binomial distributions take form x equal to x plus r minus 1 c r minus 1 p to the power r q to the power x. Okay. Now x equal to what? Number of failures. Is failure positive or negative thing? Negative thing, right? But here x was what? Number of success. Success is positive, right? Right. In binomial distribution, x equal to what? And success is positive thing, right? And here x equal to what? Number of failures, right? And r equal to what? Number of successes. X equal to number of failures. Okay. And p equal to what? Probability of success. Q equal to 1 minus p, probability of failure. Okay. Here, this is a random variable RV. Random success is the random variable. Here, this is the random variable. What is the definition of random variable? Random variable is a mapping from sample space to real line. Okay. Random variable, it has certain probability of occurrences. Okay. That is the way. For example, age, height, weight, body mass index, that could be just variable. Okay. It could be variable. It could be random variable. It could not be random variable. But random variable is a variable that has certain probability of its occurrences. Clear, right? It will occur with certain number of with certain probabilities. That is called the random variable. Do you see the difference? So what is the difference then? What is the difference? Now let's try to give you the most realistic example. Most realistic example is that in this case it is number of failures. Okay. And you do not know number of failures, how many failures, 0 failure, 1 failure, 2 failure, how many failure will happen before getting a specific number of success R. What does that mean? That means in negative binomial distribution, data is generated by targeting a specific number of successes. Up until you obtain a specific number of success, the trial will continue. Understand? On the other hand, binomial distribution, everything fixed. A hospital has 50 patients. Okay? A club has 60 members. a class has 40 students fixed. On the other hand, the negative binomial data is generated one by one. For example, this quiet boy sitting in the front table, he decided to invite me, my wife, and my two daughters for a lunch at his home. You understand? And he asked, Professor, what do you like to eat in the lunch? What do you like to eat? I said that I like salmon fish very much. He said, well, I know how to catch the fish. I will catch the fish. So he went there. He put his angler in the river up until he get how many fishes? 4. His purpose is to serve 4 fishes, right? So he put his angler, clever fish, 2 kg bait. So failure, right? Again, failure. Again, failure. He got first success in the 4th try. So how many failure? 3, right? So how many success he got? 1. How many more success he need? 3 more, right? 3 more. Then again put. So in this way, he will get. So for example, take a look at that. How many way he gets successes? This is one way. This is second way. That is third way. That is many ways. Maybe I want to put here 10 ways. 10 ways he can. He got the failure, 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 success, success, failure, failure, success. Right? He can get success, failure, 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 success, success, failure, failure, suppose like this.
4 success.
He needs 4 successes, right? So that means in this case, he got success, success, success. But once he got the last one, then he is done, right? Right? So here 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So here he got the final success. He got the final success. But see, these combinations and that combination are different, right? Here, failure, 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 success, success, failure, failure, success. Here, success, failure. This is different, right? Right? So he can get many ways the successes. When he got the last success, that means he stopped there, right? So the negative binomial distributions, the data is generated up until he got a specific number of successes. So this part is just the binomial. This part is just the binomial. So let me write it in this format. See whether you are convinced by looking at this. So 1, 2, 3, 4, 5, 6, 7, 8, right? 8. So among these 8, so he got 5 failure, he got 3 success. Okay? 1, 2, 3, 4, 5, 6, 7, 8. And then this is the last one, right? This is the last one, right? So number of failures is 1, 2, 3, 4, 5, and success 1, 2, 3, 4. So 5 plus 4 minus 1. This is a X. This is a R. This minus 1 what? This minus 1 that one, because binomial is running on this 8. So that is 5 plus 8 minus 5 plus 4 equal to 9. 9 minus 1 equal to 8. Binomial is in this format. Okay. So then C, and then 4 minus 1. This is number of, and then you are getting success, right? Probability of you are getting 3 successes, and then Q, you are getting how many failures? You got 5 failures, right? You got 5 failures. 1, 2, 3, 4, 5. And then finally that one. When that one you got, you stopped. So this is completely binomial. This is completely binomial. This is what different arrangement is possible. It will be success, success, failure, 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 success, and then finally success. Last one is always success, right? So that means last one is always success. That one equal to that one, and this part is a binomial. Are you understanding? So the way here different combinations are taking place. Here different combinations are taking place. That combinations is written in this format. Are you understanding? Yes.
You're telling like the last success which we get, then it's called binomial.
Is called negative binomial.
It is binomial.
Once you add that one, then you stop, right?
So we get all successes in first item. Like for example, you said fishes.
Okay.
We got the fishes for at what do you call it?
First four items.
First four items.
Yeah.
We call it as again.
It is still negative binomial. In that case,
Irrespective of failure.
yeah. Why? Because x equal to 0 failure, right? So that means here you will plug 0. It will be, let me write here. If according to his advice, 0 failure, 4 success, -1, and 4 -1, right? According to your opinion. Now, p to the power, how many successes? 4 successes, right? And q to the power what? 0. 0 successes, right? So that means what are you getting? You are getting 4, you got 3, choose 3. 3 choose 3 successes. 3 choose 3 successes can be obtained only one way. 3 choose 3, which could be written at factorial 3, factorial 0, factorial 3, which is equal to 1. 3 successes can come. Success, success, success. All of these success can happen only one way. That is the only one way, right?
Why can't we use binomial for this case?
Sorry?
Why can't we use binomial for this case?
Okay. Who can answer his question? His question is, why can't we use these things? Binomial is the number of successes, x. X equal to number of successes. But here x is number of failures. Understand here? X equal to number of failures. You went to the apple tree. You want to get the apple from the apple tree by stoning. Understand? I want to find that probability that you want to get 4 apples from the apple tree by stoning. So you can get success after stoning 10 stones. You can get 7. I can get maybe 100, right? You understand? So the situation is different. So why it is called negative binomial, that explanations I have given you. Take a look at that. In this case, so one way 4 success can be obtained like this way. Another way 4 success can be obtained like this way. Another way 4 success can be like this way. Fourth way 4 success, different ways. How many different ways the 4 successes can be obtained? That could be mentioned in here. Sorry, 3 successes can be obtained. That is mentioned in here. When final success is obtained, then it is negative binomial. Are you understanding, online people, or you need to explain it to me one more time?
If you could explain one more time, please.
One more time, okay. Take a look at that. Okay, now let me explain these things more clearly, why it is called negative binomial distributions. Your purpose is to obtain. Could you talk later? So now I am going to explain it more rigorously. Your purpose is to have, like, how many successes are equal to 4 successes you want to get. 4 fishes you want to catch. But the fish catching is coming like one after another, one after another. You put the angler, you got the failure. Okay? You put the angler, you got the failure. You put the angler, you got the success. You got the angler, you got the success. Failure. Again, you got the failure. Again, you got the failure. And then you got the success. So this is the 3 successes. Our target is what? 4, right? So now, once you got the 4, then you are done. This is my 4th one. Okay, you will stop. Now take a look at that. You got the success, success, failure, 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 success, and then you got this one. Okay. So our x equal to what? X equal to number of failures. How many failures? 5. Okay. How many failures? X equal to 5. And R equal to number of successes 4. R equal to number of successes 4. Then in that way it will continue, right? Another one we can get failure, 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 and then failure, success, success, success. And then this is the final one when you will stop. This is the stopping point. Clear, right? This is the stopping point. Now my question is, for this success, I want to express these things in the probability format. How can I express this in the probability format? For this success, probability is P, which I put in there. Okay. Now among these, how many different ways these 3 successes and 5 failures can happen? That can happen 5 plus 4 minus 1. 5 plus 4 minus 1 and 4 minus 1. Because how many successes is in there? 3 successes. 1, 2, 3. 4 minus 1 equal to what? 3 successes, right? And 5 plus 4 equal to total number of trials. Total number of trials, 5 plus 9 minus 1. So that means I am ignoring the last success. Last success I just put there. I don't want to include it in there. So how many way 3 successes among the 8 trials can happen is mentioned in there. See, there is 8 trials. 1, 2, 3, 4, 5, 6, 7, 8, right? So among 8 trials, how many way 3 successes can happen? See, this is P to the power 3 and that is Q to the power 5. Okay? And then when it will add with that, then it will be, so 5 plus 9, 8, C, 3, P to the power 3, sorry, P to the power 4, this and that, and Q to the power 5. That is the way negative binomial distribution has been formulated. Clear right now? That is very beautiful art.
Yeah.
Clear, right? Okay. So failure means what? Negative. And success means positive. And you have seen how it is formulated, right? The way binomial data generated, the negative binomial data generation is completely different. Okay. Now, these things, these distributions can also be written as probability of x equal to x plus r minus 1 c r minus 1 p to the power r q to the power x can also be written r c x p to the power r q to the power x. These two things are same. I'm going to show you now that thing, okay? So first of all, you clearly understand what is the difference between binomial and negative binomial distribution. Binomial distribution, the variable x represent number of successes, but negative binomial distributions, the variable x represent number of failures. Right? Negative binomial distribution data generate each trial. So each trial ended up with success or failure up until you get a desired number of success, which is predetermined. But you do not know how many failures will happen. Clear, right? Now let me show you how these two things are same thing. Yes.
Is there a difference between distribution and regression?
Okay. Distribution and regression. In the regression, you are doing prediction, right? When you make predictions, there is a certain probability from where those things are coming from. Okay. So underlying distributions for the regressions, usually simple and multiple regression are normal distributions. Okay. But when you want to predict count data, the normal distribution does not work. So that is why you need a Poisson distribution. Poisson distribution is a probability distribution that you can predict with certain probability. Similarly, negative binomial distributions is a probability distribution. So your question is, why distribution things is coming? Because these distribution things are put in the regression format to come up with the prediction model for the count data.
So then if you predict any data, then you need to use
Distributional assumption is needed.
the base of the regression.
Yeah, based on the distribution. Regression based on the probability distributions. Otherwise, otherwise from where you will bring probability? Do you understand now? Okay. So now let me show you these things. So minus r cx can be written as minus r factorial x minus r minus these things, which could be written very clearly like this. That could be written as factorial x minus r minus x factorial. And if we take out minus r minus 1 and minus r minus 2, all the way if you take, then you will get minus r minus x plus 1, and then you will get minus r minus x. Okay. If you take out, it will give you like this way, this format. Okay. So that part and that part is cancelled out. Now let me show you x plus r minus 1 c r minus 1. That could be written as x plus r minus 1 factorial, and then r minus 1 factorial, and then factorial x. Okay. So I want to keep here factorial x and r minus 1. So now if I want to write like this one, x plus r minus 1, x plus r minus 2. If I go all the way, then we will have x plus r minus x, and then x plus r minus x minus 1. So these cancel, and then this is a factorial in here. This and that cancel. This and that cancel. Okay. So now if you take out this, this part and that part is cancelled. So this matching with that. Now, if you take a minus sign common from there, this part is matching with that part completely. Okay. So that's the reason it is called negative binomial regressions. These two quantity matches. These two quantity, if you take the minus signs out now, if you will say 1 minus sign, 2 minus sign, all of these minus signs, if you take out, then they exactly match. Okay. After that, now so you have seen how geometric how negative binomial distributions come into an existence, and why it is called negative binomial distributions. Now take a look at that. Last class, I told you this is the Poisson regression model. And in this regression model, I have shown you lambda, right? This is the thing I have shown you in last class. So the mean of the Poisson random variable is in the model. This is what I have shown you in the last class. Clear? Now, question? No? Okay. So see, Poisson distribution has its mean parameter lambda. So lambda is in there, right? But for the negative binomial distribution, x plus r minus 1 c r minus 1 e to the power r and q to the power x. We want to find the mean of this expected value of x. If you want to find the expected value of x, 0, 1, 2, up until infinity, then what we are getting, x equal to 0 to infinity, x plus r minus 1 c r minus 1 p to the power r q to the power x. Okay. Now let me write these things. As this is constant, we just want to take out these things. And then I want to write here x equal to 0 to infinity, x plus r minus 1, r minus 1, and then factorial x, q to the power x. This is called the geometric series with power r, r plus 1, r minus or something like that. If I start giving all of this proof, then I think I need at least 1 year to 2 semesters. Okay, so I will avoid some of those things. But if you are interested to learn these things, how these math derivations come, I want to see the proof, then please stop by. Okay. Now from there, what I want to do, I want to take q and p to the power r, and then it will go in here. X takes value 1 to infinity, 1 to infinity, and then there is a, if I take 1 r, then it should be factorial r and then r. And then there is a x plus r minus 1 factorial, and then also there is a x minus 1 factorial. Take a look at that. These x I take, cancel out with that, and it will reduce to x minus 1. This reduced to that. I make it here factorial r, I added a r there. Okay? A r is added there, and I make it factorial r. And then 1 q I take out, so it is q minus x. Okay? Now, any question? You have question? Did you have a chance to take a look at the homework too? I will discuss today, okay? Homework 2 is just the applied part, but you need to understand what's the background. That's the graduate study, okay? Undergraduate classes, we discuss just some applications and some computations, but graduate class, this type of training is necessary. So from this line to this line is just some algebraic manipulation, okay? So now this could be written as r q e to the power r, and it takes value x equal to 1 to infinity, and it could be written as x plus r minus 1 c r, and q to the power x minus 1. The way we came from here to there, and some mathematical manipulations, these things could be written like that way. Okay? So now r q p to the power r, and then if I plug the value x equal to 1, 2, 3, then I got r c r and q to the power 0. And if I 2 here 2, then r plus 1 c r q, R plus 2 C R Q square, R plus 2 C R Q cube, all of these gone. Clear? If you just plug the value of x's. These things could be written like that way. R cube p to the power R 1 minus q to the power R minus R plus 1. These things could be written like that way. These things could be written like that way. Again, please, if you do not understand these things, stop by in my office. I can give you detailed descriptions as well as proof for this. Okay. Now that could be written as R cube p to the power R. This is equal to coming 1 minus q to the power R plus 1, which could be written as R cube p to the power R 1 minus q equal to p to the power R plus 1. So we have R q over p. R q over p is the mean. Is the mean of the negative binomial distributions. R q over p. Understand? So mathematically, I have shown R q over p is the mean of the negative binomial distribution. Clear, right? Now take a look. That was the Poisson distribution e to the power minus lambda, lambda to the power x over factorial x. It has a mean equal to lambda. But this is the negative binomial distribution x plus r minus 1 c r minus 1, and then p to the power r q to the power x, and it has a mean equal to r q over p. These mean exist in these distributions, but that mean does not exist in this distribution. Do you understand? This mean which you derive mathematically exist in this directly, okay? But that R Q over P does not exist in there. Regression means what? Regression means we are fitting a line which is an average line, right? This is what, right? This is the average line, right? Regression means this, right? Average line. Why mean is important? Because all the regressions that you are doing, it is average. On an average, you are predicting. Why I am talking about the mean? Because mean should be in there so that I can make on an average prediction. Do you understand? Okay. I'm not going to derive the variance, but the variance of negative binomial distribution is this. Variance of x equal to RQ over P square. Okay? RQ over P square. In your homework problem, I have given a data sets, and where there is a two variables CEB, one, another one is CEB2. In your homework problem, I say use this variable as a dependent variable for Poisson predictive model or negative binomial predictive model. Okay, so what you will do, you will find the, are you listening? You will find the mean and variance of this. If they are equal, then what regression model you are going to use? Poisson. And you will find the mean and variance of this one. If their mean and variance are not equal, you are going to use this one. See, Poisson regression has a expected value of X, variance of X equal to lambda, right? Among these two dependent variable, which has a same or approximately same mean and variance, that variable will be used as a dependent variable for the Poisson regression model. But for the negative binomial regression model, expected value of X equal to RQ over P, which is not equal to RQ over P square, which is the variance of X, when X is a negative binomial random variable. Are you understanding? Clear, right? Yes.
So in negative binomial, even though if we know mean, we cannot predict the probability. Right?
So tell me again.
In a negative binomial, even though if we know the mean, we cannot find the probability.
What do you mean by that?
Like here, if we know lambda, we can find probability. Lambda is directly there in probability equation.
No, probability you will find lambda is the value of the rate unknown parameter which should be given, or you have to estimate the lambda from the axis. Understand? Once axis is given and you can estimate lambda, then you can estimate probability from there, Poisson regression model. Okay? From the Poisson probability model. Okay, that is one. But this Poisson probability model, I do mathematical manipulations and then finally run the likelihood functions to bring it in the format of a regressions, because lambda is expressed as a linear combination of the covariate. If you remember last time, like what I did, I take log of lambda equal to a combination of covariate, log of lambda equal to x beta and lambda equal to the power x beta, if you remember that thing. Because of lambda, why I did log of lambda, why I did log of lambda? Because lambda is the mean of this. So I am taking log of lambda as a linear combination of the parameters. Why I am taking lambda? But in such a case, I cannot do these things because the mean parameter is not in there. This mean quantity is not in there. So I have to make mathematical manipulations on these negative binomial distribution so that these negative binomial distributions, final expressions will have a mean format. We'll have an expression for the mean format. So you are talking about like predicting probability from regression, something like that.
Yes.
So what we will do in here, Poisson probability has been used to set up the predictive regression model. Okay. After regression model set up, we predict the dependent variable. We predict the number of accidents, number of awards, okay, number of phone calls. That is what we are predicting. Why we are predicting that things? Number of, because I am using the count data probability distribution, Poisson distribution. Okay. So I will stop the recording here.